Hey, this is Mrs. Frazier, and I will be going over your test review with you so you can use this video to help you through that. Okay, solve the following equations. So to solve this first equation, the first thing I want to do is get rid of my parentheses, because remember, this doesn't really mean 3x minus 5, but it means 3 of x minus 5. So I'm going to distribute my 3. So I'll have 3x. 3 times minus 5 or negative 5 would be negative 15. So 3x minus 15 equals 5x. And it's minus 3 minus x. So I want the opposite of 3 and I want the opposite of x. So really this is going to become minus 3 plus x. So looking on both sides, I have like terms. On my right side, I have 5x and x. So I'll go ahead and combine these. So now I have 6x minus 3. And now I'll start to solve for x. So I'm going to subtract 3x from both sides, so then I can have x on one side. Now I have 3x minus 3 equals negative 15. I'm going to add 3 to both sides. And I have negative 11 equals 3x. And I'll divide by 3. So x equals negative 11 over 3. Oops. Okay, looking at B. Again, I'm going to start by getting rid of my parentheses. So I'm going to take negative 0.5 and multiply by a and 16. So I still have negative 0.3a. Now I have minus 0.5a minus 8. On my other side, I'll have 0.8 times a, which gives me 0.8a, plus 0.8 times 15, which gives me 12. Okay, on my left side, I have some like terms that I'm going to combine. So I have negative 0.8a minus 8 equals 0.8a plus 12. I'm going to add 0.8a to both sides. So that leaves me with negative 8 equals 1.6a plus 12. And then to get a by itself, I'm going to subtract 12 from both sides. And now I have negative 20 equals 1.6a. And I'll divide by 1.6 on both sides, because we always divide by our coefficient. And I get negative 12.5. So a equals negative 12.5. Okay, number 2, how many solutions does each of the following equations have? No solution, one solution, or infinitely many, and why? So we're just going to begin by solving each of these and seeing what if they have one solution or no solution or infinitely many. So looking at our first one, I'm going to distribute. I'm going to get 6x minus 3 equals 6x minus 3. And I don't really need to continue this. These are identical equations on both sides, or identical expressions on both sides of my equal sign. So that tells me, since they're identical, identical expressions. It means that there will be infinitely many solutions. Okay, looking at my next equation, 5x plus 4 minus 3x minus 7. So I'm going to go ahead and solve this. I'm going to start by, I'll just rewrite that. I'm going to add 3x to both sides. I get 8x plus 4 equals negative 7. Now I'm going to subtract 4 from both sides, and I get 8x equals negative 11, and I'll divide by 8. So x equals negative 11, 8. So this would be one solution. Okay. Okay, moving on to negative 3x plus 7 plus 4x equals x plus 9. I'm going to do that down here. So first I'm going to combine my negative 3x and my 4x, which makes x. And I'm going to have x plus 7 equals x plus 9. So I actually can already tell that this is going to be no solution. One reason I can tell is that my coefficients to my variable are the same. So as soon as I subtract, and I can continue this, I'm going to subtract x from both sides. That's going to eliminate my x's, and now I have 7 equals 9, which is a false statement. So no solution because the expressions are not equal. Well, the expressions can never be equal. Okay, 8x minus 6 equals negative 2x minus 4 plus 2 times 5x minus 2. So let's simplify this a little. I know I have negative 2x minus 4. This becomes 10x minus 4. Okay, let's combine our like terms. So I have negative 2x and 10x. And I'm also going to combine negative 4 with negative 4. So negative 2x and 10x makes 8x. And negative 4 and negative 4 makes negative 8. So 8x minus 6 equals 8x minus 8, which is almost just like the last one. So I can see that my coefficients are the same, but my constants are different. So as soon as I subtract 8x from both sides, I'm going to get 0. And I'll have negative 6 equals negative 8, which again is a false statement. So this is a no solution because I have a false statement. Okay, solve the following inequalities and graph their solutions on a number line. Okay, I'm going to start with my distributive property. So I have 12x minus 20 is less than 6x plus 4. I'm going to subtract 6x from both sides so I can get my variable on one side of my equation. I'll be left with 6x minus 20 is less than 4. I'm going to add 20 to both sides, which gives me 6x is less than 24. And then I'm going to divide by my coefficient 6. So x is less than 4. Notice we kept our less than sign all the way down. We didn't divide by a negative at the end, so we don't need to flip our sign. So my solution is x is less than 4. And to graph it on a number line, I'll have 4, an open circle since it's less than and not equal to. And all my numbers that are less than 4 will be to the left, so I'll shade to the left. Okay, and the next one, I am going to begin by adding 2x to both sides, eliminating my variable on the left side. So now I have 4 is greater than or equal to negative 2x plus 8. To get my variable on its own or isolated, I'm going to subtract 8 on both sides. That leaves me with negative 4 is greater than or equal to 2x, or I'm sorry, negative 2x. And now I'm going to divide by negative 2. Now, since I divided by negative 2, I need to flip my sign because I divided by a negative. So now I have positive 2 is less than or equal to x. That means x is greater than or equal to 2. To graph on my number line, I'll have 2. I'll have a closed circle this time because it can be equal to. And I want numbers that are greater than or equal to 2. So greater than 2 would be to the right. So I'll shade to the right. Okay, number 4. Amanda was asked by her math teacher to solve an inequality on the board. Amanda put the following on the board. Did Amanda make a mistake? And if so, what did she do wrong? Okay, so going through and checking each one, we can see that first, that Amanda took negative 2 and distributed. She distributed negative 2 times x, giving us negative 2x, and negative 2 times negative 1, giving us a positive 2. So that looks like that is a correct step. Then to get 1x, Amanda combined my like terms. So that gave us 1x is less than or equal to 2x minus 12. So it also looks like that Amanda went ahead and subtracted 2 from both sides, which is also correct. She subtracted 2 here and subtracted 2 from the negative 10. So far, Amanda's doing everything correct. The next step that she did, it looks like, is she subtracted 2x from both sides. So by subtracting 2x on both sides, that gave her negative 1x is less than or equal to negative 12. So the next step that Amanda should take is divide by negative 1. And since she's dividing by a negative, she should flip her sign, giving us x is greater than or equal to 12. So her mistake is Amanda did not flip the symbol. She did not flip the inequality symbol when she divided by negative 1. Okay, number 5, write an equation to represent the graph below. So to write an equation, I need my slope and I need my y-intercept. And I'm writing it in the form of y equals mx plus b. So slope and y-intercept. We need to get really good at this. This is going to be very important for the rest of our semester in algebra. Okay, so to find my slope, I'm going to find my rise over my run. So I can see I'm increasing by 20. For my y, or my rise, so my change in my y is 20. And the change in my x is going from 1 to 2, so 1. So 20 over 1 is my slope, which would just give me 20. My y-intercept, we can't really see, but if my line continued, my y-intercept would be 0. So my equation is y equals 20x. We don't need to put 0. Number 6, write an equation to represent the table below. Okay, so again, I need my slope and I need my y-intercept. So I can see that my table, my change in my y is decreasing by 1.2, and the change in my x is increasing by 2. So negative 1.2 divided by 2 gives me negative 0.6. So my slope is negative 0.6. Okay, my y-intercept is a little bit more difficult to find. So I'm going to use my formula, and I'm going to choose an x and a y value from my table. So I'm going to choose 1 and 2.4. 1 and 2.4. So I have 2.4 equals negative 0.6 times 1 plus b. So negative 0.6 plus b equals 2.4. I'm going to add 0.6 on both sides, and I get 3 equals b. So my y-intercept is 3, and I'm going to check this. I'm going to make sure I'm correct. I'm going to check it with my next one. So I'm using my 3 and my 1.2 now. I have y equals negative, I'm sorry, let me fix that. Oh no, we'll keep it. Negative 0.6, and we're using 3, okay, for my x value, and we're adding 3 for my y-intercept. Okay, so we're plugging in my x value here, and we're using my y-intercept that we just found to see if we're correct. So negative 0.6 times 3 is going to give me negative 1.8. And if I add 3, that should give me 1.2, which is not. So now we need to go back and we need to fix something. So I must have made a mistake somewhere. Okay, actually I did not make a mistake. My mistake was that I am not adding my integers correctly. So negative 1.8 plus 3 does give me my y value of 1.2. Okay, and that's what I wanted to get. So that means I must be correct. So my equation is y equals my slope, which is negative 0.6 times x plus my y-intercept of 3. Okay, write an equation to represent the line that passes through the points 2, 3, and negative 4 and 9. Okay, so again, I need my slope and I need my y-intercept. So to find my slope, I will use my slope formula, y2 minus y1 over x2 minus x1. So I'm going to do 9 minus 3, and then negative 4 minus 2. So I have 6 over negative 6, which gives me negative 1. So my slope is negative 1. So just like we did with our table, I'm going to use my y equals mx plus b. I'm going to choose one of my coordinates, so I'm going to choose 2 and 3, and I'm going to plug it into my formula. So I'm going to plug in 3 for y, negative 1 for my slope, so negative 1 times 2, my x value, and I'm looking for b. So negative 2 equals 3. Still looking for b. I'm going to add 2 to both sides. So 5 equals B. Again, we can check our work. So I have y equals my slope, which we said is -1. And we're going to choose an x value. So I'm going to choose -4. And I'm going to add 5, my y-intercept. So -1 times -4 gives me +4. 4 plus 5 gives me 9. So my y would be 9, -4, and -9. So that was one of my coordinates above. So my y-intercept is correct. So my equation is y equals -x plus 5. Okay, write the first 4 terms of the sequence described by the given functions. Okay, if I look at A, my first term is 12. My first term is 12. So if I would like to find my second term, I know, if looking at the function rule that they gave me, I can also tell that my common difference is 7. Common difference is 7. So my first 4 terms then will be 12, 19, 25, and 32. So all I've done is add 7 each time. Another way to look at this one is if I look at this is like my function notation. So if I was looking for my second term, 2 minus 1, I would end up with f of 1. So that means take my first term and add 7. If I was looking for my third term, and that would mean 12 plus 7. That would give me 19. If I'm looking for my third term, I would take f 3 minus 1, which gives me f of 2. So that means I'm taking my second term and adding 7. My second term is 19. 19 plus 7 is 25. And so on. So we can see the pattern that comes from that. Okay, looking at B, my first term is 10.5. And looking at the rule that was given to me, I can see my common difference is -4. So I'm going to have 10.5, and then I'll have 6.5, and then 2.5, and then -1.5. Okay, number 9, write the first 4 terms of the sequence described by the given functions. Okay, so looking for my first 4 terms of these sequences, this is a little different. They haven't given me my first term, so I'm actually going to have to use my function rules. So I'm going to begin with 85 minus 2 times 1 minus 1. So that gives me -2 times 0. So again, all I've done is plug in 1 to n for my term. So I have 85 minus 2 times 0. 2 times 0 is 0. So I have 85 minus 0. That gives me 85. So my first term is 85. Okay, I can continue my process, but hopefully you're going to start to see something. My first term was located right here. But we can go ahead and find our second term now. So I'm going to go through the same process, 85 minus 2. Now I'm going to do 2 minus 1. 2 minus 1 is 1. So I have 85 minus 2 times 1, so 85 minus 2, and I get 83. So now I have 83 for my second term, and I can keep going, but hopefully you can see that my common difference is this negative 2, so it's going to decrease by 2 each time. So I have 81 and 79 to continue my pattern. Okay, so now looking at this next one, I could go through the same process, but now we know that this is my first term. So I'm going to start with negative 12. And this here is my common difference. So I'm going to have negative 12, and then I'm going to add 2.5. So that gives me negative 9.5. And then negative 7.5. And then negative 5.5. Again, we could plug in to our n. Every single time we could plug in 1, 2, 3, 4 to be sure that we're correct, but it's not always necessary. Okay, number 10, write a function for each sequence in the form of explicit, recursive, and slope-intercept form. Okay, so if you look back at the last two examples we did, number 8, those were the example of the recursive formula. So 8 was recursive. And number 9 was an example of the explicit formula. Okay. So let's start with the recursive formula because it's actually the easiest. So first we need to find our common difference. So I can see my common difference here is adding 4 every time. So my recursive rule is A1, I'm sorry, AN, or we can say TN. So any term can be found by taking my previous term and adding 4. It can also be written as this, F of n equals F of n minus 1 plus 4. Okay, so slightly different, but this is using my function notation. Okay, my explicit rule. My explicit rule is when we take my first term. So I'm going to have AN equals 26. I'm going to add my common difference, plus 4. And remember, I want to multiply 1 less than the term I'm looking for. So n minus 1, right? Because if I'm looking for my second term, I add 4 one time. If I'm looking for my third term, I add 4 2 times. If I'm looking for my fourth term, I'm adding 4 3 times. So I always want to take 1 away from my n value. Okay, and one more form. I have my slope-intercept form, so I have y equals, my slope is 4, so I would have 4x. And in this case, with my slope-intercept, I want my 0 term, so I'm going to back this up one more time. I'm going to get 22. So I'm going to add, this is my 0 term, I'm going to add 22 instead of my first term. So I can also write this as y equals 22 plus 4x. Okay, B. Okay, to find my common difference, I can subtract. I can see that I am, if I do 26 minus 41, I can see that I am decreasing by 15 each time. Okay, so starting with my recursive formula, I know that I'm going to take my term. To find any term, I'm going to take my previous term, so a n minus 1, and I'm going to subtract 15. So if I'm looking for my second term, I'm going to take my first term and subtract 15. If I'm looking for my third term, I'm going to take my second term and subtract 15. Okay, my explicit rule, to find any term, I'm going to take my first term. I'm going to add my common difference. In this case, it's minus 15. And I'm going to do that one less than the term I'm looking for, so n minus 1. Okay, and then my slope-intercept, I need my 0 term, so my y-intercept. So I'm going to back up one more time, which gives me 56. So I'll have y equals 56 minus 15x. Okay, or I might have y equals negative 15x plus 56. Number 11. The value of y varies directly with x. Write an equation that represents the relationship between x and y if y equals 13 over 5 when x equals 25. Okay, so the first thing that I felt I needed to do is I wanted to change this to a decimal, only because I know for direct variation to find my equation, I need to figure out how much of it is for 1. So I need to be doing y over x to get my slope or my k value. So I am going to do 2.6 divided by 25. By doing this, I get 0.104. So my equation is y equals 0.104x. And number 12, the amount of money Kelly spends at Redbox is directly proportional to the number of movies she decides to rent. If 14 movies cost $17.50, what will 3 movies cost? Okay, so first I want to find out how much one movie costs. So I'm going to take $17.50 and I'm going to divide by 14. So essentially I'm doing y over x again, my y value being my cost, my x value being my movies. Y over x. So $17.50 divided by 14 gives me $1.25. So my equation is y equals $1.25x, or I could say my cost is $1.25 per movie. So 125n. So if it's 3 movies, I'll just plug it into my equation, $1.25 times 3, and that gives me $3.75.